Welcome back, my friends. We are building the Hungry and Traveling Snake, the snake game with a twist for the YBite Python curriculum available at www.ybyte.in. As you can see on my screen, we have the capability to have the snake move, make it turn, but remember the main objective of this game is that snake must eat the food that has been put out for it, let's say all around the park. We are going to do that in this video. Basically, those foods, just like in Scratch, will be additional turtles. Now remember, we needed more than one food, so I'm going to create a variable over here. Let's say call it, n, say foods, and I'm going to set it to 10. Of course, you can set it to another number too. And I'm also going to create a list to store all these foods. Now we'll talk about this, but this is actually very interesting because we are going to be creating a list of turtles. Now, just like in Scratch, we had a separate sprite which was a fruit. Here we are going to create many turtles, in this case 10 turtles, that will become the food for us. And the way we do that is just using a for loop. So I just say, okay, look, let's say for KK in range, let's say n foods. So basically I want to create n foods, turtles. So I do that by calling, let's say my turtle as a food this time. So I say, okay, food is a turtle. Okay, a little careful. Say turtle dot turtle. So this creates a turtle object for me. But remember, turtle objects gets created. I'm going to stop this for the moment. The turtle object gets created in the center of the screen with its pen down. So I'm just going to say, well, food dot pen up. Now I do this so that when the turtle object is moved, it does not create a marking on the screen. So I do this. I'm also going to remove any kind of animation on this. So I just say, okay, speed is, let's say 0. Now remember, this has the effect of making the go-to block in Python turtle exactly like the go-to block in Scratch, which means the turtle immediately goes to where you want it to go. I'm going to also set it to say a square. Doesn't really matter. You can, choose any shape here. So I just say, for example, food. Okay, food dot shape is, say, square, and I'm going to set its color. Now again, this is just, doesn't really matter. You can set to anything that you like. So I'm going to set its color to, let's say, red in this case. So snakehead is blue, the food is red, and I'm going to make this food go to. So I just say food dot go to, say random dot rand int, let's say minus 200 to 200. Now this is just numbers so that food gets randomly distributed all across the park. So I specify the x value, and I also specify the y value. So that's how this looks right now. It says food dot go to, let's say random between minus 200 and 200. Also, and this is very interesting, like I said, I'm going to create a list of these foods. So I'm just going to say list of foods, say append dot append. Remember, append is like adding item to the list, and I'm going to add food to this list. Now we'll talk about this list a little bit later, but an interesting point here is that in Scratch we could create sprites, but we could not put them in a list. Now here we are doing exactly that. We are creating sprites, or say turtles, and also we are putting them in a list which we can manipulate later on. So let's see this working. Now when I run my program, notice the snake head is there, but I've also got all these other food items coming up. They are randomly sprinkled around the park, and that's the whole objective of the game, that snake must eat all this. I run it again. This time round, again there are 10 foods, but notice they are all in different places, and that is happening because I'm sending them to a random position on the X and the Y grid. Now, just for the sake of, let's say, illustration, say I did not do a pen up. So if I did not do a pen up, now when this code runs, we notice that all the turtles do move to different places, but they leave a mark behind them because remember the pen is actually down for each of them. So I don't want to do that. I avoid this from happening. Let's say I did not do food.speed is 0. Now this is also interesting. You will see that it takes a while for the turtles to reach the final location. So you can see the turtles are appearing and slowly going to the different places. So we don't want that to happen. We want it to look very instantaneous. That's why I put food.speed is, let's say, 0. Remember, we have also put this in a list. So let's just briefly see what this list actually contains. I just say print, let's say list of say foods. Now we know this is a list. Let's just run this code. Notice on my console, I get this, things printed out. This is a list and we have turtle objects, 10 of them created at different memory locations. Now, this is very interesting. In fact, from our code point of view, we have named it all as food, but because they have been created again and again, they are all at different locations. And now this list contains them. In fact, we will deal only with this list going forward. We will not deal with food per se because all those items have been appended into this list. Remember, as the snake moves around, this is going to catch these foods. There's going to be no particular order because we do not know whether food 0 is here or food 0 is here or food 1 is where. Snake is going to catch each of these in different orders. We will need a list again to keep track of which food has been caught and which is yet to be caught. Now, for that purpose, I'm going to create a list here. I'm going to call it, let's say, eaten, or you can call it any name, doesn't really matter. And I want this to be all booleans because it's either eaten or not eaten, which means either true or false. I'm going to just set it all to false to start with. Now notice the way I do that is I call it a boolean, I make it false, but I put the square brackets outside it and I say multiply this whole list by, let's say, n foods. Now this is quite interesting. Basically, we have created a list here, exactly same number of items as the foods. So which means 10 items and each of those items is a false. So if I were to, let's say, also print, say, eaten, uh, we will get what we are looking for, which is, let's say, all of those items would be false. So it's basically the first one was a list of turtle objects. The second one is a list of booleans, but there are exactly same number of items on both. In fact, there is a perfect correspondence. Now here we have created a very concise code which makes me the list that I wanted. But in fact, we could do it differently. We could do it the regular way using the same loop as here. So I can say, look, eaten dot append, let's say eaten dot append and say false. Now what this will do is exactly like we are appending to the list of foods here. I'm going to append a false to this list eaten, and hence the impact will be exactly the same. We can verify that when I run this code now. Notice I get a list again created, eaten, which is all false, and the list of foods as earlier. Now, just one point I want to make here. We will go with, let's say, this approach because this is also quite neat. In which case, I don't need this, this statement here. Now, look at this for loop, and this is quite interesting. Look at this for loop. In fact, yes, we are repeating. Remember, for loop is always a repeat loop with a variable. However, this case, notice that we are not really using the variable, which means that we can do it a little bit differently. We don't really need to define a variable. I can just have an underscore and it will do the same job for me. So it's like, yes, I want to repeat something, but I don't really need the variable here. So I'm just going to put an underscore here. The impact will be exactly the same. So I get those 10 turtles. My lists are created because notice even for the list, I'm only appending. I'm not indexing any specific item. So this is another way of writing this for loop because I do not need this variable. I hope this has all been clear. Before we wrap this up, let's just sort of consolidate what we have been talking of. So notice we created the snake food, put it in a list of turtles, which is actually very interesting, very different from scratch because we can't do these things there. Well, not to my knowledge at least. We created an empty list and then we populated this list using, let's say, a for loop. Like I said, over here, instead of KK, I could have used an underscore, which basically says that, okay, look, repeat all this for this many times, but I don't really care about the variable. And that's sometimes used quite nice in a way. We have this list caught which we have created. We use this code, but which, as we saw, it is exactly same as appending it in the loop. I called it eaten in the video, but you can also call it caught. Doesn't matter. The name really doesn't matter. The intent is what is important, that we are going to keep track of which food has been eaten through this list. So graphically speaking, what we have done is that we have created two lists. Both lists have n food items. In the first list, which is list of foods, each of these is a turtle object. In the second list, we have all booleans. There's a perfect correspondence. So if this food has been eaten, this will become true. If this food has been eaten, this will become true. Now, as I said, we do not know to start with in which order the foods will be eaten, and hence this list are needed. I hope you found this interesting. In general, if you think this way of learning by building activities, applying concepts, seeing them work makes you understand things better, look at our website and you'll see many, many such activities. Take care. Thank you so much. Bye bye.